Bright Tuty. Every student matters.
Hello students, this is the 16th chapter of your syllabus, that is light. Now students, in this chapter we are going to study how we are able to see objects, what are the different laws related to the vision, right? So let us start with the first topic, that is what makes things visible. Students, how are you able to see things? If you do not have eyes, you won't be able to see things, right? There are people who are visually impaired, they are not able to see because they have some defects in their eyes, right? So we are able to look at the objects, we are able to see our surroundings because of the sense of sight, because of our eyes, right? Now students, we are able to see mountains, rivers, trees, plants, chairs and a lot of objects around you. You can see everything. Why is this possible? And at night, we see the moon and stars as well. Now students, just imagine there is total dark and there is no source of light. Will you be able to see any object then? Now can you see any object in the dark? Is it possible for you that it is totally dark? Can you see any object? No, it is not possible to see any object in the dark because we are able to see substances when the light from the source falls on us, falls into our eyes. For example, we have a light source, say a tube light, and you are standing here, right? Now there is a table present here. How are you able to look at this chair, at this table? How are you able to see this chair? This is because the light from this tube light falls on this table and then goes into your eyes. This is how we are able to see objects due to the light present around us, due to the light falling into our eyes. This is the concept of how we are able to see objects. You can notice that when the sun is down, it's night time and you have no tube lights on and the room has no source of light, you won't be able to see any of the objects because there is no origin of light and there is no reflection of light as well. So, we are not able to see any object in the dark because there is no light present and hence no light is falling into our eyes, which makes it impossible for us to see things in the dark. As I told you about this concept, this is the tube light, this is the table and these are your eyes. You are able to look at the object because the light from tube light falls on the table and then into your eyes and hence you are able to look at the table. So students, we are able to look at objects because first reason is because we have eyes, we have the sense of sight, while the second reason is that we are only able to see the objects because of the light present around us that falls into our eyes and hence we are able to look at the objects. So students, this was an introduction about how we are able to see objects. This is the second topic of your chapter, that is laws of reflection. Now students, in order to understand how we are able to see these things, there are some laws that you firstly have to understand in order to get a better image in your mind. Now students, there is a picture in front of you. In this picture, there is a mirror, right? This is a comb and there is some light source through which light is coming towards the comb. Now what is the first step that you do? You take a comb and you close all its openings except one. You close all the openings. Now you can see this is a comb only, there is only one opening. As you can see, this is the opening. Rest of the openings have been closed, right? Then you have a mirror placed behind the comb, right? Placed behind the comb. Now what you have to do is you have to take a light source. What can be a light source? It can be a bulb, it can be anything, right? Now for example, you have taken a bulb. Here is the bulb. This is the bulb, which is the light source for the experiment. Now this bulb is throwing light towards the comb and then this comb filters this light, obviously because there is only one opening, so a small narrow beam of light will be able to cross through the comb. So this is the area through which the light enters and this is the narrow beam that you can see. This is the narrow beam that can pass through the comb. Now what happens is, as soon as this ray passes and it falls on the mirror reflects the light into another direction. There is a totally different direction into which the light moves. It is the same amount of light. There is no change in the beam. You can see in this picture as well that the amount of light that is incident on the mirror, this is the incident ray, and this is the reflected ray. We will be studying the definitions as well. First of all, you just have to understand that there is a light source which is throwing light on the comb, and then comb is filtering the light through which a narrow beam can only pass, and that beam, after falling onto the mirror, reflects back, right? So this is what we are talking about here. This is an experiment, and what do we conclude after this experiment? After striking the mirror, the ray of light is reflected in another direction. After striking the mirror, the ray of light is reflected in another direction. The light ray which strikes any surface is known as the incident ray. As I told you in this diagram, this one is the incident ray. The light falling onto the mirror is the incident ray. Then the ray that comes back from the surface after reflection is known as the reflected ray. Now students, this was the incident ray. This ray fell onto the mirror and then it got reflected into another direction, and after reflection the ray is called reflected ray, right? So what did we learn? That a narrow beam is incident on the mirror and it is getting reflected. The ray that is falling onto the mirror is known as incident ray, and the ray that is reflected after the reflection is known as the reflected ray, right students? So this is one of the laws of reflection. A ray of light is an idealization basically. In reality, we have a narrow beam of light which is made up of several rays. There is not only one ray. One ray will not be visible to us. One ray is negligible to us. There are a number of rays that make a beam. And in this experiment, the beam that you saw, the light that you saw was a beam, not the ray. Ray is just one, beam is a combination of rays. And that is how we can see. Right students? For simplicity, we use the term ray for a narrow beam of light. Just for simplicity, for an easier concept, we use ray instead of beam, right? So that we can explain the action of the light with the help of one ray, not a collection of rays, right? Now students, what you have to do is, how do we understand this experiment now? What you do is, you take a chart paper, you have set this experiment on the chart paper only. This is the chart paper, white chart paper, or any white paper you can say. You have taken a white paper. Now you have marked the positions of mirror, right? Now here is the comb and here is the opening. So from this opening, this incident ray is coming, right? This incident ray is coming and this is the reflected ray. Now what you do is, just to the perpendicular of this mirror, you draw a normal. This is a normal, right? This is the normal, and the ray is this ray, the reflected ray is this ray, this is the incident ray, and this is the reflected ray, right students? Now what you do is, exactly at the perpendicular of the mirror, you draw a normal that is at 90 degrees. Now, what does the diagram look like after this? You have removed all the objects. You have only marked the objects that were already present and the narrow beam of light as well. Now, what is the diagram finally? This is the mirror. This is the incident ray, as you can see. This is the direction from which the incident ray is coming. Now, this is our normal that is perpendicular to the mirror. Now, students, the angle between the incident ray and the normal is known as the angle of incidence. This is the angle between the normal and the incident ray. This angle is known as, this angle in whole, as a whole, is known as angle of incidence. This angle is between the normal and the incident ray. Remember, not between incident ray and the mirror, but between the normal and the incident ray. Similarly, after reflection, this light reflects into this direction, right? Now the angle between this reflected ray and the normal, which is this angle, this angle we are talking about. This was angle incident is angle 1 and the angle of reflection is angle 2. This angle is known as angle of reflection. Basically, we are telling that how much is the ray deflected, right? This is the perpendicular ray from which we are measuring the deflection of each of the rays. Angle of incidence is the angle between the incident ray and the normal, while the angle of reflection is the angle between the reflected ray and the normal. So now we know about angle of incidence and angle of reflection as well. From this diagram, we can construct that diagram again. Here was the mirror, here was the comb, right? Now, there was a narrow beam of light coming towards the mirror from this comb. This now is the mirror and hence this is the normal, right? Because it is completely 90 degrees towards the mirror. Then this is the reflected ray. This was the narrow beam of light, this is the normal. Now, this is the angle of incidence and this is the angle of reflection, right? Now, students, there is also one thing that for normal reflection, for reflection on a regular surface, the angle of incidence is equal to angle of reflection. This is one rule that you will be studying about later as well, that angle of incidence is always equal to the angle of reflection, right? Now, students, what is the conclusion? Angle of incidence is always equal to the angle of reflection. This is one of the laws of reflection. This is one of the laws, that angle of incidence is always equal to the angle of reflection. This law helps us in drawing many other conclusions about light, about the images that are formed on a mirror and in our eyes as well. You will be studying that in higher classes also, that angle of incidence is always equal to the angle of reflection, right, students? Now we have another experiment in front of us. It is a very interesting experiment. In this experiment, you have to take a stiff chart paper, and you have to fix all your apparatus on the stiff chart paper. Now, earlier you had a softer paper, you have now to take a very stiff paper. Now, what you have to do is, this is your table basically. Here is your table. You have to put the paper in such a way that some of the paper is away from table. For example, that this is your table. Now you have to put the chart paper in such a way that this chart paper is falling out of the table as well. As it is stiff, it won't fall down, but it is crossing the table in some manner. So this is the area of the paper that is beyond the table. Table is only up to this level. This is beyond table. Right, students? Now, what you do is you perform the same experiment. You have taken a torch, that is the light source. This torch is producing light that is falling onto the comb. This is the comb again. The light is falling on the comb. Here we have a mirror. And simply the light is falling onto the mirror and it is getting reflected, right? It goes all the way to the chart paper. It can be shown to the point where the chart paper exceeds, right? You can see the light falling onto the chart paper that is beyond the table as well, right? Now what you moderate in this experiment is that you have the chart paper again, the similar experiment, it is happening, and then you have to fold this chart paper downwards. This was the portion of the chart paper that was outside the table. Now you softly fold the paper. Now what you see, you can only see the beam of light up to this point. You bent the paper. Now the beam of light cannot be seen on the outside part. There is no light seen on the outside part. So students, this is what I was talking about. We are only able to see objects when light falls onto the object. If there is no object, we won't be able to see the light as well. We are able to see this beam of light because there is a chart paper and it is falling onto the chart paper and the mirror, right? So this portion earlier was in the plane, right? This all structure earlier was in a plane, but as soon as you bent the paper, the reflected light got into a different plane, right? This is the chart paper and you have bent the corner of the chart paper. Now the light is coming and here up to here it is in the plane, so you are able to see the light. But as soon as the plane is different, the light goes into a different plane and you are not able to see the light on the chart paper. So what are we talking about here? That the angle of reflection, the angle of incidence, the angle of reflection, the normal, are all in the same plane. Right? This all is happening in one plane only. There are no different planes. As soon as a different plane is seen, the light beam disappears. So this tells us that light, the angle of incidence, the angle of reflection and the normal are all in the same plane. Right, students? So what did we observe? That earlier when the chart was not folded, the light beam was visible on the chart paper beyond the table as well, right? Because it is a stiff paper, so it basically holds on to itself and hence the light remains in the same plane. As soon as you fold the chart paper, the light disappears. Right? These were the observations made. Now what is the conclusion? The conclusion that we draw from this experiment is that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. What did we learn? That the incident ray, the normal and the reflected ray all lie in the same plane. What are we talking about here? This is our normal, this is our incident ray and this is our reflected ray, right? Now this is incident ray, this is the normal and this is the reflected ray. All the three, 1, 2 and 3, all the three lie in the same plane. This is what I was telling you earlier as well. This is the conclusion that we draw from this experiment, that the incident ray, the normal and the reflected ray all lie in the same plane, right? Now students, there are some important questions. You have studied about reflections, a little bit about reflection in class 7th as well. Now can you answer this image? Can you answer these questions? When you learnt reflection, the image formed after reflection, was the image erect or upside down? Do you remember that whether the image formed was erect or upside down, or was it of the same size of the object? For example, you have a bulldozer in front of you, you have a truck. Now you can see it into a mirror, but is it the same size of the truck? No, obviously. Did the image appear at the same distance behind the mirror as the object was in it? For example, this is the mirror and here is the object A. Now, was the object A at the exact distance inside the mirror, behind the mirror, right? So these are some important questions. Could it be obtained on a screen? Can we obtain that image on a screen? These are some important questions that you have already studied. We will be answering these questions in this lecture only. So students, before we go into these questions, we have a topic named lateral inversion. Before we go into the definition, let us look at this experiment. Now students, this is a source of light. O is source of light. Now this source is throwing light on a mirror PQ. Mirror is PQ, right? It throws the light OA and OC. This is point A, this is point C. These are the two incident rays, right? They are falling onto two different areas of the mirror, two different points of the mirror. Now as soon as the light falls, it gets reflected. The reflected rays are, for OA we have AB and for OC we have CD, right? This is the OA and this is its reflection, right? And for different, I'll be using a different color for the second ray. This is OC, wait, this is OC and this is CD, which is its reflected ray, right students? So now you understand there are two rays and both of them have different incident angles and different angles of reflection also. Now what are we trying to understand from this image is that, students, as you saw that the OA was before the point C. C is here, A is here, right? Now what do you see? After reflection, the rays of light, the ultimate position of the light is somewhat different. Let us see. Earlier, the OA falls on point A and gets reflected to point B. Now, A was, when you look at the actual image, this is the image, right? This is the area where on the mirror the rays are falling. Now, OA is, you have to look at the object first of all, that this is the ray OC and this is the ray OA. Now you can see that OA is under OC, right? OA is under OC while OC is above OA. What you see after is when OA reflects and forms AB and when OC reflects and forms CD, now AB is above CD. The position has been reversed. Earlier OC was above, now OC after getting reflected is underneath AB, right? It is somewhat behind the C. They have interchanged their positions, right? Earlier you can also understand from the left right concept that earlier OA, let me write with the help of a different color. Earlier OA was in left and OC was in right. Right? OA is in the left while OC is in the right. After reflection, OA gets reflected and forms AB. Now this AB is in left and OC gets reflected to form CD and this is now in right. Right? Now you have seen that the positions are same but they have interchanged them. Right? You have an inverted image in front of you now. The object as seen, the original object is not seen in the similar position that it was present. We see an inverted image. You can also understand this with the help of a mirror. Simply, when you stand in front of a mirror, if I am watching this, if I am wearing this watch in my left hand, in the mirror it will appear that I am wearing it in my right hand, right? You can notice that at your homes as well. You can wear any kind of cloth or any kind of accessory. You will see that the object in the image appears inverted. It is not the exact same. If I have worn something on my left, it will appear to be on the right in the mirror. So what have we learned? That this is the lateral inversion. We see the inverted image in the mirror. Now why is that so? I just told you that the rays get reflected due to the mirror and we obtain a laterally inverted image. Let us look into the definition now. In an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. This is what I was talking about. In this case as well, the objects present in the left appear to be on the right, while objects present on the right appear present to be on the left. This is the lateral inversion. From this diagram, you can understand that in a very good way, that earlier OA was under OC, now it is above OC after reflection, right? So this is what we have learned from this experiment, lateral inversion. So students, this was all about lateral inversion. This is the third topic of your chapter, that is regular and diffused reflection. Now there is a picture in front of you. As you can see, there are some parallel rays falling. These are the parallel rays. Let me take a different color. These are the parallel rays falling onto the surface. Parallel means that they are never going to intersect. They are always parallel. There is no point at which they will be intersecting. The angle between them is 0 degrees. Now this is an uneven surface, uneven, or you can say irregular surface. There is no regularity, it is a very random surface, it has ups and downs in it. So what happens after the incidence is that instead of having the same angle of reflection, they all have different angles of incidence as well. This is the angle for this ray, this is the angle for this ray, this is the angle for this ray, this is the angle for this ray. You have to basically draw the normals to the perpendicular of the mirror. Basically, we have to take the surface as the mirror. Now, if we draw the perpendiculars, you will see that they all have different angles. Let us see. This is the normal. This is the mirror here. So, this is the normal. Now, in this case, this is the mirror here. So, this is the normal, right? In this case, this is the mirror. So, this is the normal. We have to draw the perpendicular. Now, in this case, this is the mirror. So, this is the normal. In this case, this is the mirror, so this is the normal in itself basically. In this case, this is the mirror, so this is the normal. So, you can see that for all of them, angle of incidence is different. So, it is understood that the angle of reflection will also be different. As you can see in the pictures, the ray 1, 2, 3, 4, 5, 6, I have named the rays 1, 2, 3, 4, 5 and 6. The ray 1 goes into this direction, the ray 2 goes into this direction, ray 3 goes into this direction, ray 4 goes into this direction, ray 5 goes into this direction and ray 6 goes into this direction. They were coming from the same direction in a parallel manner. This was a beam of light, but after reflection they have scattered. They have gone into different directions. This is because of the irregularity on the surface. Irregularity in the surface. So, when there is some irregularity, what happens is the rays have different angle of incidence and different angle of reflection. So, there is the scattering of light basically, right? They are no more parallel to each other. They have moved into different directions. This is because of the irregularity of the surface. When all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. You saw that the reflected rays were not in the same direction as the incident rays. So, this kind of reflection is known as diffused or irregular reflection, right? Remember that the diffused reflection is not due to the failure of the laws of reflection. It is caused due to the irregularity in the reflecting surface, like that of a cardboard, right? It is due to the irregularity of the surface. It is not always mandatory that laws of reflection have a flaw. No, they do not have a flaw. They are completely correct. Only the matter is that the surface was irregular, hence we could not see a regular reflection. Now, this is the perfect scenario. Here, what do you see? You have 1, 2, 3, 4, 5 and 6. Now, you have a regular surface. This is a regular surface. There is no irregularity, right? Now, what is happening? The normal for all of them will be same. The normal will be same for all of them because the surface is same, right? Now, angle of incidence is also same for everyone. For every ray, the angle of incidence is same. Similarly, as angle of incidence is same, angle of reflection is equal to angle of incidence. So, the angle of reflection is also same for every ray. Hence, you see that the rays come parallel and then after reflection also they stay parallel to each other, right students? So, this is due to the presence of regular surface and this kind of reflection is known as regular reflection. This totally depends upon the surface of the basically the surface on which we are carrying out this experiment. Reflection from a smooth surface like that of a mirror is called regular reflection, right? Images are formed by regular reflection. By regular reflection, we cannot form an image because obviously the rays are going into random directions. But when we have a regular surface, then only we can see reflection. You cannot see your reflection in sand, right? On a door. No, you cannot. You can only see your image in a very smooth surface, that is a mirror, because there is no possibility of irregular reflection. Here is only regular reflection, so you can see your image in a mirror. So, this is all about reflection, diffused and regular reflection. Now, do we see all objects due to reflected light? We have to understand that why are we able to look at these objects, what is the concept? Nearly everything you see around is seen due to reflected light. Nearly whatever you see around you is visible to you due to reflected light, right? Moon, for example, you have solar system in front of you. You are able to look at the moon because it receives light from the sun and reflects it. That's how we see the moon. This is the sun, for example, right? This is the earth. Now here you can understand that there is moon when it is revolving around the earth. The light from sun falls on the moon and then the light falls on the earth, and that is how we are able to look at the moon. This smaller smaller sphere is moon and the medium sphere is earth. So the sun throws light on the moon and then moon throws light on the earth. The light gets reflected, and that is how we are able to look at the moon as well. So the objects which shine in the light of other objects are called illuminated objects. There are some objects which shine due to the presence of light of an object. They are illuminated objects. There are a number of objects that you have around you which are illuminated. Then there are other objects which give their own light, such as the sun, the fire, flame of a candle, and an electric lamp. All of these substances produce light by themselves. Their light falls on our eyes. That is how we see them. The objects which emit their own light are known as luminous objects. The sun, for example, is a luminous object. Right? We have illuminated objects which we can see due to their shine when light falls on them, while luminous objects are the substances where the light is produced by them by themselves only. We are able to see them because they are throwing light at us. Right, students? So this was all about how diffused and irregular reflection occur, and why do they occur? Because of the irregularity in the surface. And then we basically see that why are we able to see the objects. This is majorly because of the reflected light, but some other cases are illuminated objects and luminous objects which have a different case. Right, students? This is the fourth topic of your chapter, that is reflected light can be reflected again. Have you seen any example around you where you have seen that light once reflected gets reflected again? How is that possible? There is a picture in front of you. In this picture, there is a barber and there is a student who has gone there to get his hair trimmed. Right? Now, after the barber has cut his hair, he brings a mirror in front of the main mirror. This is the main mirror 1 and this is the mirror 2. He brings a mirror in front of the first mirror so that you can look at the back of your head. How is that possible? How is this happening? Basically, the light is getting reflected multiple times so that you are able to look at the back side of your head. Now what is happening here? The light from your head is falling back onto this mirror, and then this light is falling onto this mirror. This light then is again falling into your eyes, due to which you are able to look at the back of your head. So yes, a light that has been reflected can be reflected again, and this can be done multiple times also. What is the typical example that you have around? When you go into a dressing room, in any showroom, in any outlet, when you go, there are changing rooms inside there. So when you are into a changing room, there are mirrors in front of each other. This is a mirror and this is a mirror. So you see many images of yourself. You cannot even count the number of images on both the mirrors, because there is constant reflection on the mirrors of the light that is falling onto you and onto the mirrors. So there are innumerous images that are formed. Right, students? So this is how we say that light can be reflected again. The light that has already been reflected can be reflected again also. Now students, the periscope makes use of two plane mirrors. What is a periscope? Let me draw a diagram for you. Periscope is a scientific appliance. What happens is, this is how we make a periscope. Right? This can be used for you to look outside when you are inside home. Right? What is happening? There is a mirror here and there is a mirror here. Right? This is a periscope. What happens is, the light from outside enters into the periscope, then is incident on the mirror, and then this light gets reflected to the second mirror present inside the periscope. Now this light comes out of the periscope, and here you have your eye through which you are able to see the light, see the object that is present here. Now what is happening? What is the application here? We are simply reflecting the light once gets reflected here and then again gets reflected here. So we see multiple reflections. Right, students? So this is an application of multiple reflections present inside a periscope, and basically what we talked about is that reflected light can be reflected again. There are many examples around you. You can look for them for yourselves. You can bring a mirror in front of a mirror and put an object between both of them. You will be seeing that there are multiple images of that mirror, of that object in both the mirrors. Right? So this is how we learn that reflected light can be reflected again.